Hello everyone, Aaron here, and welcome back to Leetcode. Today we are doing the concatenation of consecutive binary numbers problem. Given an integer n, return the decimal value of the binary string formed by concatenating the binary representations of 1 to n in order modulo 10 to the 9 plus 7. Okay. So, example 1, n equals 1, so we're going to take 1 in binary, which is 1. We're going to do 3, so that's 1, 2, and 3, so that's a 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, and that's a 27. Same thing with 12, but it gets huge. 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0. Yeah, so that carries on like that. What's the pattern here? 2, 1, 3, 2, 1, 0, 3. No, I thought there might be a pattern emerging there somewhere. Well, there is obviously a pattern emerging, but I don't quite know what it is. Anyway, that gives you a huge number, which is larger than 10 to the 7, so you do a modulo. Now, 10 to the 9 plus 7, that's 10 cubed roughly. 10 cubed is roughly 2 to the 10, so that's roughly 2 to the 30. So if we work within a 32-bit integer, we will always be working within our 10 to the 9, and then we can just do our last little 10 to the 9 at the end. That just saves us ending up with huge, long things that we can't quite handle. At its core, it's quite simple. For I in range 1, n plus 1, I need a result. The result is equal to 0. Result is equal to result bit shift k, some k, ORed with I. All of that done modulo 2 to the power of 32. Return result modulo 10 to the power of 9 plus 7. Now, the tricky part is k. How much do we shift the current thing by? One, we're going to shift it by 1. 2, we're going to shift it by 2. 3, we're going to shift it by 2. I think we need to store, well, okay, so one way to calculate this is its log. So why am I worrying about this first to begin with? Well, basically, I need to shift the result by a certain amount because the 1 has shifted along, well, initially it shifted along 1 to make, shifted along 2 to make room for these two things, and then the whole result was shifted along by another 2 to make room for these 2 bits. The problem is, how did I know it was 2 bits that I'm going to put in? Because on a computer, all numbers are just a certain number. Now, in Python, I think if I just did bin, k is equal to bin I. In fact, I can do this with len bin I minus 2. And that's because if I do bin of a number, it gives me 0, b, then the binary representation, and I think it just gives me the binary representation with no leading zeros. Is that fast enough? That's probably very fast. So let's see what happens. Yep, that worked. Use all the example test cases. Wrong. Show me what the binary representations are at each step. So 1 is fine. 1 1 0 1 1 1 1 0 1 1. That's fine. That's good. So the mistake gets made here where it's grown too long. It's punted off, what, 1 bit on the end? Is this the correct trailing bits, though? You know what? Let's not do this cleverness. I think I've made a mistake with that optimization, because being modulo 10 to the 9... Actually, I could work. I don't know if concatenation will survive modulo though. So hang on, let's do it without that clever optimization. Python has big ints. It'll be fine. I'm just checking the bounds on this. If n can go up to 10 to the 5, that means the total sum can reach something near 10 to the 10. Does 10 to the 10 fit in a 32-bit integer? Because that's 2 cubed, 2 to the 10 cubed times 10. Yeah, that how many bits is it? 2, 4, 8, 16. Yeah, that'll hold, I think. Yeah, you'd want to do it in a 64-bit int in a language that it doesn't have infinite integers. Just in case, because there's a chance that'll spill out of a 32-bit integer. Anyway. Yes, this is a wee bit of a cheat. Not gonna lie. It may be too slow. It is too slow. Is it this line that's slow? Or is there a constant time solution? Let's just steal that and stick that in the test cases. So I'm trying to think if there's a nicer way to do this. We kind of want to know where the leading 1 bit is, but that's difficult. Scene is 0, target is 1. Scene plus equals 1 if scene is equal to target shift is equal to 1. Scene equals 0. Shift plus equals 1. Target time equals 2. So this little concoction here, I think, is going to let me count how many bits I'm expecting to move. So in the first round, I need to see just one thing. In fact, let's do this scene later, because it's after I've processed everything. I still want to actually see the binary result. No, I don't. I'm worried about speed at the moment. So, how many numbers of a particular bit length am I expecting to see? Well, no, that's not quite what I'm asking here. I expect to see twice as many numbers that contain n plus 1 bits than I do that contain n bits, assuming we're counting the minimum number of bits needed to represent it. So that's why target has to double each time. I only expect to see one target to begin with that results in a shift of 1. Then I need to see 2 that will result in a shift of 2. Then I need to see 4 that will result in a shift of 3. So that's what this scene is doing. It's resetting each time we update the target and the shift, and it's just incrementing every other time. So let's see if that works. That did work, but is it too slow? Well, only one way to find out. It does save us a string conversion, which is usually slow. No, still too slow. What have I not noticed here? I don't know. I'm not saying much, and that's because I don't know much. What are the properties of this? It's really hard to know. Is 10 to the 9 plus 7 some special number? Well, there's no way that thing's a power of 2. No. Can I do this in log time? If I... Maybe I need to go back to doing this mod 10 to the 9 plus 7. Because if this gets truly massive... Oh. Yeah, I did. I needed to continually work because if... Yeah, so my little analysis back here, this is working on the sum, not on the shift. And the problem is the shift grows significantly larger than the sum. Yeah. That's probably it. So we're actually really fast for some reason. Maybe that's this transform. Maybe maybe it was intended that I do it with the binary string. Or that's what everyone else did at any rate. So that's why they're using so much more time, because they've got to do a whole string conversion and they've got to allocate strings everywhere. Whereas I'm just doing a little count much, much faster. I don't know. We made an optimization, but we made the wrong one. I should have kept this in. I think we had this earlier from memory. No, we had the wrong one in earlier? I don't know. Anyway, this is a fun problem. This is an interesting problem. I'm not used to thinking with bits much anymore, so it's nice to have the little challenge. Anyway, that's it from me. Do remember to like, comment, subscribe, all of that good stuff. I do hope you have a wonderful weekend. Small programming note, I will not be uploading much next week. I'm away at another conference, Life of an Academic. But I will be back the week after, ready and raring to go. So, have a wonderful week next week, and I will see you next time. Bye.